Here's the first example of a solution to y prime equals ay. The 2 by 2a, this example has real and distinct eigenvalues for the matrix A. Okay, so we want to solve y prime is this matrix 0, 1, 2, negative 1, y with an initial condition. All right, so step 1 is to compute the eigenvalues and eigenvectors of A. So A is that matrix 0, 1, 2, minus 1. And determinant of A minus lambda I is the determinant of subtracting 1 from the diagonal, minus lambda 1, 2, minus 1, minus lambda. So that's minus lambda times negative 1 minus lambda minus 2. And I'm going to set that equal to 0. And then I expand that out. I get lambda squared plus lambda minus 2 equals 0. Circle that. That's the characteristic equation of A, right? So what is that? Hopefully that factors lambda, I don't know, plus 2. Lambda minus 1 equals 0, right? Because 2 minus 1 is 1, 2 times negative 1 is 2. Good. So just, I could call that lambda 1 and that lambda 2, but let's call this lambda 1 is 1 and lambda 2 is minus 2, just so they kind of make sense, right? Remember, I can call either one lambda 1. It's all right. So let's find the eigenvectors. For lambda 1 equals 1, I get A minus I is negative 1, 1, 2, negative 2. And V1 equals AB satisfies. All right, if I multiply this by AB, I get minus A plus B is 0, and 2A minus 2B equals 0. As always happens, the two equations really give you one effective equation, which is just A equals B. And this one also says A equals B. So we get V1 is 1, 1. All right, maybe we should summarize this a little bit. Lambda 1 is 1. V1 is 1, 1. A lot of ones there, huh? So lambda 2, which is negative 2, satisfies A minus 2I is, let's call it A, sorry, I was going through, I want to mention a little trick here. A minus lambda 2I is A plus 2I. Okay, especially when the eigenvalues are negative, it's good to take care of the subtracting the eigenvalue. Write it all out, and then give us what A minus lambda 2I is. Here's the matrix A. I'm going to add to the diagonal 2, 1, 2, 1. The two rows are the same. And now for V2 equals AB, the equation says 2A plus B is 0. And the second equation is also 2A plus B is 0, right? So, or I can solve this, probably nice to solve it for B. B is negative 2A. All right, so if I let A be 1, B is negative 2. Okay, so it's nice to avoid fractions. So V2, which is AB, is 1, negative 2. So let's write that over here. Lambda 2 is -2, and v2 is 1, -2. And remember, if everybody got this right, half the people could call that lambda 1, that lambda 2. Half the people could call that lambda 1, lambda 2. There's only two correct answers, the eigenvalues, but for the eigenvectors, everybody could have a different correct answer. All right, so let's go on. Keep that summary. I have a reason I want to keep that characteristic equation. I think I want more room though. The characteristic equation of A is lambda squared plus lambda minus 2 equals 0. All right, so the general solution to the ODE, or the vector ODE, or the system of two ODEs, is y is c1 e to the 1 times t, which I'll just call e to the t, times v1 plus c2 e to the lambda 2t times v2. Okay, cool. And that's a vector. Okay, so that's kind of, in a way, all there is to it, right? Except we need the initial condition now. So now we've found the eigenvalues and eigenvectors, step 1. We wrote down the general solution in this admittedly simplest of the 3 cases. We got the general solution, that's step 2. And now step 3 is y of 0, which is c1 times 1. I don't have to put in e to the 0 times e to the 0. Right? So I told you that's really an equation for C1 and C2. What is that equation? C1 plus C2 is 1, and C1 minus 2C2 is 0. If I had any other numbers besides 1 and 0, they just go on the right. Okay, so now I have to solve this. There's a lot of ways I could solve it. Maybe the easiest way would be to say that this means that C1 is 2C2, and then put these together, and they imply that 2C2 plus C2 is 1, or 3C2 is 1, C2 is a third, and then C1 is twice that. So the solution is C1 is 2/3, C2 is 1/3. Okay, now don't just box that and move on to the next problem, because I haven't really solved this initial value problem yet. So there's a general solution. So the solution to the IVP is going to be y equals 2/3 times e to the t times 1, 1 plus 1/3 e to the minus 2t times 1, -2. All right.